Hello everyone and welcome to the Full Stack Project YouTube channel. Today I'm going to talk about React design patterns, and if you want to get the slide deck for the subscribers of my YouTube channel, you can download it from my fullstackproject.xyz website, and if you need to download it, you should subscribe to my YouTube channel and I will share the URL for the deck. And also make sure to comment and ask questions on the comment section, and if you have any suggestions about on the ways to improve the video, make sure you mention that one as well. So welcome to the video.
Let's start with the introduction. What is React design patterns? So when working with React, developers, primarily work with building user interfaces, and also uh, developers work with managing state and application logic. That's what most of the React developers work on. So React design patterns serve as a guide to help achieve these objectives while ensuring the consistency, modularity, and the scalability of the code base. So that's what the React design patterns do. So if you try to understand the React design patterns, it's like React design patterns are predefined structures and proven methodologies that can be applied to your code base. So it's predefined and already structured, so they provide solutions to common challenges that React developers face when building React applications. So it includes component organization, managing state properly, and also in terms of performance optimization. So by following these React design patterns, you can enhance the overall quality of your code, and also you can streamline the development process of React components. And next, let's move to the key objectives of React design patterns. So these are the key objectives of React design patterns, but these objectives are common for most of the design patterns in common. So let's start with the consistency. So consistency is the design patterns that promotes the uniform approach throughout the application. So by adhering to established patterns, like let's say in this lecture we talk about React design patterns. So developers can write code that is easier to understand and maintain. So it's reducing the likelihood of errors and inconsistencies throughout your React project. And also you will see that all these five objectives are kind of interrelated to each other. And moving for the modularity section, so modularity means your React project or the React components are modularized. So this modularity allows developers to reuse the components across the application. One component is kind of responsible for a one purpose. So it's easy to debug since components can be isolated and handled independently. So that's one of the key objectives of React design patterns. Next objective is the scalability of your application. When you follow these React design patterns, it's easy to scale your React project. So this following React design patterns, it helps managing the complexity as the application grows, ensuring that the code base remains maintainable and adaptable to changing requirements. And next thing is the separation of concerns. So design patterns encourage the separation of UI presentation, business logic, and state management. So we can keep these concerns separately. So this leads to cleaner code and allows developers to make changes in areas without affecting others. For example, if you want to change the UI presentation, if you have followed React design patterns, it's easy to change the UI presentations without affecting the business logic or state management. So at the end, so this increase the code maintainability as well. And the final one is improved collaboration. So when you adapt these React design patterns, it's easy to collaborate, right? So because developers can understand and contribute to each other's code more easily, reducing the onboarding time for new team members and improving the overall productivity. Okay, let's move to the common React design patterns. So I will note down a few common React design patterns. The first one is the custom hooks React pattern. So that's the design pattern that we are React design patterns that we are going to discuss today. So, and next we have higher order components, and then we have the render props design pattern, and also we have the container and presentational components design patterns. So throughout this series of lectures, we will go through each of these React design patterns and explain with demonstrations how we can implement these React design patterns in your React project. And also finally we have these compound components React design pattern as well. And if I go through quickly on the benefits of using React design patterns, so these are the benefits of using React design patterns. So you can reduce the development time and cost, so less technical debt. So this technical debt refers to the concept in software development where developers take shortcuts or make trade-offs in the code to meet deadlines or to release the product faster. So if you follow React design patterns, it can reduce the technical debt. So example, if you, let's say you have a deadline of tomorrow, so you are following, you have to write code, without considering about unit testing and stuff, and that will increase your technical debt. So those are the things that we discuss under the terms of technical debts. And other than that, you can reduce the cognitive load. It's kind of like making easy to solve problems and take decisions. So since we use React design patterns, our code is separately uh, coded throughout the application. Because of that, it's easy to go through the application and understand the code for a new developer. So those kind of things reduce the cognitive load and overall support the faster builds and fast production in long run of your React application. After that, let's start with the first React design pattern that we are going to talk. That's the custom hook design pattern. Let's go through the properties of the custom hooks design pattern. So first of all, you should understand custom hooks are just reusable functions. So these functions, it encapsulates the complex logic, making components simpler and easier to maintain. So the logic is inside a separate file. You can import the custom hooks in a single line of code, and the code is encapsulated in that imported custom hook. So it's simpler and easier to maintain. And the next thing is custom hooks often uses the React built-in hooks such as useState, useEffect, and useContext, and so on. So when we go through the demonstration, you can easily see what I'm talking about here. So normally, if you want to, let's say, talk to another API, or you'll have to use useEffect, and if you have to manage state and output those states to reuse inside the components, you will have to uh, use state hooks and so on. So as I said earlier, we can import these custom hooks easily inside our components and make use of it. And let's talk about when to use custom hooks. This is also very important. So these React design patterns, those things should be used on the optimum level, right? You don't want to use all these React design patterns on everywhere. There are specific use cases. With experience and with time, you will understand when and where to use these separate design patterns. So when to use custom hooks, so if you want to share logic between React components, you can use custom hooks. And if you want to hide the complex logic, that we in programming terms we call it as abstraction, so we can use React hooks if you want to abstract logic and use inside a component. For example, let's say you have to have some logic to manage state, or if you need some logic to uh, optimize the response that is coming from an API endpoint. At that point, whether other than using the same code block on every component, you can use a custom hook and hide the complex logic and use that custom hook inside a component, and also reuse the same hook throughout your application. And also, if you want to follow the single responsibility principle, that's moving the business logic to a custom hook and components, keeping the presentation UI inside the React components, you can use the custom hooks. And also, if you want to organize side effects and stateful logics, as I said earlier, API calls and subscriptions, those are some examples for side effects. We can move them to React hook without cluttering the component. So, for example, let's say multiple components need to track the window size or the mouse position. We can create a separate hook and name it as use window or use mouse position, and we can use it throughout your React application. And also, let's talk about when not to use custom hooks, right? This is also very important because you have to know when to use, and also you have to know when not to use custom hooks. So when the logic is more specific to a single component, you don't have to use custom hooks, right? Because this logic is specific to a single component, and you most probably won't use this component throughout your application. For example, checkout component, let's see. So if you have some logic specifically to do the checkout process, you don't need to build it as a custom hook, since we are not going to use it on every time and so on. So, and if the logic is not very complex, you don't want to add it, since it, like, using custom hooks, it adds unnecessary complexity as well. It adds a separate layer, so sometimes it will affect the complexity. And also, the next important point is you have to consider about the performance also, because when we, let's say, we are adding a lot of calculations or heavy calculations, it could affect the performance of your overall React application. So be cautious on custom hooks that have heavy calculations and API calls, because it might add extra re-renders to your application. And moving forward, let's have a look at the ground rules of creating a custom hook. So these are the ground rules that you have to follow when you are creating custom hooks. So most of these rules are presented in React documentation. You can have a look. So to get started, hook names always should start with use, and it should be followed by a capital letter. For example, use hover, or else use mouse pointer, those kind of things. Use screen size. Always your custom hook name should start with the use key, right? And also, hooks must be called at the top level, like after the imports and all. And hook should be called inside React functional components, or inside other custom hooks. This at the moment, like most of the new React applications are based on functional components. You can't use React custom hooks on class components, right? And avoid side effects in the main body of custom hooks, right? If your custom hook requires performing side effects such as API calls and subscription, use built-in hooks like use effect, or use layout effects, or those kind of. Don't try to like use these side effects at the top level of your application. So these are some of the rules that you follow when writing normal React functions and so on as well. And now let's move to the demonstration of the custom hooks. So this is a sample project that I use custom hooks to handle API responses and to handle the API output and error handling and so on. So I will share this sample code with you so you can go through it and learn and try to see how I have used a custom hook called use users to handle everything inside this UI. For example, you can see I am rendering a list of users, and this is the page this page.tsx. That's what it's rendered in here. So you can't see any of the API calls in here, right? In this component, I only handle the UI, right? That single responsibility, that's the modularity that I'm gaining by using custom hooks, right? So this component, it only uses the UI part. Like you can see, if it's loading, I'm displaying some the loading like this, and if there's an error, it displays another set of UI, and here that's how I have rendered the list of users. So if you see all these functions, for example user and the error and everything is getting from this use users. So this is a custom hook. So I have created a separate folder called hooks, and inside I have use users custom hook. So this is the implementation of the custom hook. I have used TypeScript as well, and in here you can see I have used use effect to call the fetch users. So I am handling all the API calls and everything in this use users custom hook. And also I have used use callback to stop unnecessary renders. And in the next slide I will go through some of the frequently asked questions of the of this demonstration that I'm displaying here. And the most important thing is, like, this is a function, right? But the difference is, instead of a UI, for example in here in the page.tsx, we return a UI, right? Starting with the div and everything, we return a UI. But in the custom hooks, have a look what we are returning. We return a set of constant or set of variables, rather than or else we return a set of functions rather than a set of UI, right? uh, we return delete user function, fetch users function, and also users constant here, and load in variables, error variables, and so on. And we can directly use these return values inside our page component. So this is how I have used uh, created a custom hook inside to handle the use state from the JSON placeholder API and display it in the UI. So whenever I load these custom hooks, it triggers the use effect, it calls these fetch users, and it gets all the values, and then it returns these values as separate variables, and I'm using those variables inside the page.tsx to handle my UI. So that's how we implement custom hooks, and that's how we use custom hooks in the side of to render the UIs. So from the UI side, we can delete users and also we can refresh users. So everything works perfectly without any hassle. And let's move to the frequently asked questions from my demonstration. So why use callbacks? You can see I have used use callbacks inside the uh, inside my custom hook here. Use callback here and use callback here. This is not necessarily related to custom hooks, but I will share with you why I have used use callbacks. It's to maintain the stable function references in re-renders. So you know the use case of use callbacks. This renders only one time, so there's only one reference to the fetch users function, right? So if we don't use callback, what happens is every re-render the reference to this fetch users changes. So every time this fetch users changes and the use effect got triggered, and it's kind of a cyclic conversation, cyclic method that's happening without stopping, right? Since I have added fetch users inside use effect, so we have to use callback here to stop the unnecessary re-renders, right? So since dependency array is empty, this function is created once and never recreates it. If we have a look why fetch users added to the use effect dependency array, so here you can see I have added fetch users to the use effect. It's mostly following kind of rules of the React hooks. It's a kind of best practices that we do. So it makes the code more maintainable and future proof. At the moment, there's no any variables that is passed to the fetch users. But in future, if fetch users changes and if it's depend on another set of variables, then it's better to add fetch users here at the beginning. And also it's a kind of role in the React hooks. So guys, that's it for this tutorial here, or else this lecture here, and I will share all the uh, presentation slides and everything on my website, and if you are a subscriber to my YouTube channel, you can get it for free from my website. So I will continue this series in future as well, so make sure you subscribe to my YouTube channel and drop a thumbs up, and also make sure to add any comments or questions that you would like to know in future in this video.